All right, so here's another example from carts and pulleys and tension. So you're going to see this in your modified Atwood lab, and I don't want you to panic, so I'm going to show you this video. So again, don't panic, just unfold it. So we've got a cart sitting on a table, and it's attached to a pulley, and at the end of the pulley, we have another mass that's hanging. Okay, so we've got this 8 kilogram cart sitting on the table on a track, and it's attached by a pulley to a hanging mass of 6 kilograms. And we're trying to figure out how this thing is accelerating and what's kind of driving the acceleration. So again, it's super important to just draw a really good free body diagram. Okay, so I'm not going to go ahead and solve this for you, but I am going to show you how you should draw your free body diagram so that you can properly unfold this. So we've got the force due to gravity. We'll call this mass 1. And you know what? I'm not going to, let's erase that. Let's do this here. We've got force due to gravity on mass 1. We've got tension. We have tension. And then we have, and remember those should be connected, and then we have force due to gravity on mass 2. If we unfold this, which we can, you're going to have something like this. You've got Fg1, you have tension, then we have another tension, and we have Fg2. So you got to be careful that you don't unfold the other side because it's already essentially unfolded. So force due to gravity 1's going to stay there. But force due to gravity 2 gets flipped over. Okay? So now you have these 3 forces in your x-plane, in your horizontal plane. So those are the only ones we're going to want to worry about with our net force equation. So the sum of our forces in the x direction is really just going to be equal to Fg2 because we have those 2 tensions that cancel out. So sum of our forces in the x direction is going to be equal to Fg2, but we still have 2 masses. So we're going to use the total mass times the acceleration. So that's something to be careful of. That's how you're going to start these off and solve for acceleration. But again, you need to make sure you use your total mass. And then when you do tension, so I'm going to write total mass, tot mass. And then when you do tension, you're going to have to be careful to use only 1 mass. Okay, so that should get you started thinking for the lab, the modified Atwood lab. Okay, hopefully that helps. Let me know if you guys have any questions.